Good morning. Thank you for joining the September 27th, 2018 VOLTHA call. We have a fairly full agenda today. We do have a demonstration, some code walkthrough, some discussion on OLT adapters, and then introduction of another OLT for VOLTHA support. And so we'll get started on that. Keep in mind, we do record this to post it to YouTube, so you need to be aware of that when you're doing presentations and during discussions. With that, I am going to hand it off to Don and others at the Foundry for the Abstract-OLT demo. So Matt, I will give you presentation rights.
Yeah, let's see, where do I do that?
Okay, so you should have presentation ability.
Okay. There we go. Give me a second. All right, does everybody see that? A very functional, very pragmatic black screen.
Yes.
Yes.
He's a bash schnob. Actually, though, it's going to be Z shell when you go to my laptop. All right, so you were going to bring up. Okay, so just I don't want to spend a lot of time on the prep work, but the idea behind Abstract-OLT was, in our case, AT&T's data models for their provisioning and management systems are designed around a Nokia 736X chassis. I guess the amount of effort to design something around a SIBA pod was such that it made more sense, at least in the short to mid-term, to abstract the SIBA pod so that it looks to the OSS as if it's a 736X chassis. 736X chassis can take up to 16 line cards with 16 ports each, and for AT&T's internal decisions and testing, we will allow up to 64 ONTs on an XGS-PON port. And there's all kinds of algorithms for determining S&C tags and other things. So what Abstract-OLT proposes to do is present a SIBA pod to the greater OSS and BSS systems at AT&T as if it's just yet another 736X chassis.
And this was a fundamental SIBA requirement. The northbound abstractions support looking like a PNF, like a previous kind of network element, and so we're making good on that.
So a little about the software. It's written in Go. It uses gRPC, and there's a REST interface as well. But protocol buffers generates all that stuff. There's also a client. Actually, you could flip over to, we've covered that.
You can go here to the client side.
So there's a client that I've also written that allows you to exercise the different functions of the Abstract-OLT, starting with an echo. Basically, make sure you have connectivity and you're running the right libraries, etc. You can run the echo and it'll just bounce back a message. To start with, you have to seed the Abstract-OLT with a chassis, an abstract chassis. So in AT&T's world, we would have a SILI that would define where that is, and you map that to an XOS Tosca interface, both address and port. I mean, you can see if you wanted to highlight that, that would be, well, I was just the whole command line, but
Right.
But you can see it. You can tell, you know, whether you want to run SSL or have. You can also have authentication, but for the purposes of this, we're not going to be running those. But ultimately, we will define a chassis and say, for this chassis, for this abstract chassis, you will direct your Tosca YAML files at that IP address and that port. The second thing you would do is you add actual OLT chassis, such as the Edge Core or AdTran, or, you know, in a single port world, you would add a Tibit. And so that next method there adds that. So that's, you have to pass all the data that VOLTHA needs, you pass in on this. So whether it's an AdTran, you know, Tibit, whatever, Edge Core, what, if you're using OpenOLT or whatever, you know, driver you're going to use for it, kind of an internal name, but you also have to tell VOLTHA what port and what address and what port that OLT is running on. The way it works internally is you add the OLT, and in this case, it's a clean lineup because the Abstract-OLT slots have 16 ports, and the Edge Core we're using have 16 ports. But it could handle one port. In the case of a Tibit, it can handle 8 ports, and then I think AdTran showed us, I'm not sure if they're building it or they're just considering building it, but it was a 24 port. So when it brings it online, it just iterates through the physical ports and maps them back to the first available abstract port. So the next one method is the -O, provision ONT. It's currently a double call. It does both the whitelist and the push the data into SATIS through the XOS interface. When technology profiles come online, that'll likely be split into 2 separate calls. And then the final one is, well, not the final one. The next, from a management perspective, the delete ONT also. Currently, it doesn't reach over to XOS with Tosca, but it does clear internal mapping so that you can then provision in on top of that particular abstract port. Every call requires a SILI. The Abstract-OLT is written with a map of abstract chassis to SILI, you know, with the key being the SILI, so you can handle, you know, as many as practical. Our initial is that our initial deployment strategy will be that Abstract-OLT will be deployed with the pod, so you would only expect 1 SILI to be there, but we're not trying to limit it. The last one is the minus output. So I'm currently working on the ability to handle reboots, et cetera, on Abstract-OLT and still maintain the mappings that have been provisioned so that the OSS doesn't have to re-push those to me in a no-op scenario, or I don't have to go query and dig through XOS and VOLTHA. They don't have to supply me that information. So currently what I do is I will take the structure that represents the combination of an abstract chassis and a physical chassis. I serialize it out as JSON, write it to a backup directory, and on a restart, the Abstract-OLT will look in that backup directory for any files that have been created. The file will be the SILI of the abstract chassis. It'll ingest that and be ready to go, basically at the same state it was in when it died or got killed. So with that, I think we can just go ahead and move to the running of it.
All right.
So
I'm going to go ahead and start the Abstract-OLT server. This is will ultimately be a pod, a Helm deployed pod in the cluster here. But for now, I'm just running it within the same where it has network reachability to the pod. So go ahead and start that there. Real quick, the environment we're running in is a full 3-server cluster running Kubernetes with the recent stable Helm installed versions of the various applications, VOLTHA, XOS Core, ONOS, NIM monitoring, and the dependencies like etcd and Kafka. We're running with 1 Edge Core OLT And it's already got its drivers running to be able to actually reach into the Broadcom chip and set it up. Here you can actually see the Helm charts running already. The environment's already set up to go. And also on the VOLTHA CLI, we can see it's in its introductory state. There are no devices added. There's no ONUs visible yet. Nothing's been added. It's pretty much as if it opened up, came out of the box, ready to go to start provisioning. At this point right here is where we would actually, if you were coming from an OSS system, you would use the API to interact with Abstract-OLT to run through the API, as Don just mentioned. But for our purposes now, we will just use the CLI to simulate those calls.
Hey, Matt and Don. So the Abstract-OLT can start even before the white box is up and running, right? So everything. So is there?
Yeah, Abstract-OLT doesn't depend on anything.
Right. So yeah, I mean, another way to ask the question is that everything here can be up and running before the actual OLT itself is started and its drivers running. And a lot of times, we'll restart drivers many times over the course of running to test things out. So it just so happens we already have 208 here ready to go, but yeah, it doesn't have to be ready right now. Well, it has to be ready right now for us to be able to provision it.
I mean, VOLTHA doesn't need the OLT chassis to be running to go ahead and call pre-provision.
Yeah, that's true too. It'll just queue it up, and then let's say if it's not ready, the OLT line card, if we call it that, comes along maybe 3 days later. It will provision when it finally makes an appearance. So anyway, I'm going to go ahead and actually run through this. The first line here, like Don mentioned, is the actual creation of the abstract chassis itself. And you'll notice for AT&T folks, the terminology we use for things like NAS port IDs, racks and shelves and things like that. This is to mimic the numbering and the naming we use internally with our OSS to map back to physical location, but also algorithmically will generate the SNC tags used. So we're going to start off with adding our chassis, our SIBA pod, if you will. And let's do that. So now that that's running, we should now be able to go into SIBA, or VOLTHA rather, and actually see, hopefully, device.
No, nothing happens.
Oh, right, that's right. You're right. I'm sorry.
Nothing happens.
Yeah.
That just sets up the internal data structures.
Yes. Okay. So this feeds the Abstract-OLT itself. Got it.
And at some point in the future, some of that stuff that you guys said that you were calculating would simply just be passed down from the top, the SNC tags and the NAS ID and port ID. I mean, at some point in time, that's just going to come down with a provisioning service request, right?
Yeah, sure.
Yeah. I mean, the NAS port ID right now is the key to all of this. And given that with that string 1131.1. All the other elements decide the SNC tag. So with our BNG, it comes up with the SNC tag based on that number. We'll do the same thing. Take that number and calculate what the SNC tag should be.
Well, I guess what I'm saying is the intention was for VOLTHA to not have to have another place to calculate it, and for it simply to be passed down from the upstream, from BBNMS, who generates it in the first place. So the intention was to not have multiple places where all of that stuff is calculated, where they could get out of line and, oh, we need to change something and something else, and then all of a sudden we got to go make a VOLTHA code roll. So the intention was
keep in mind that
down.
This code here technically isn't VOLTHA code, it's Abstract-OLT code. Its whole purpose in life is to conform to the northbound interface in whatever form it is.
Right, but this is, we don't have to have this conversation now.
So it can change.
Let's move forward, please. But one question I think is the shelf. The concept of the shelf here is not individual white box, right? So I think within
it's just an AT&T thing that's always one.
Yeah.
So yeah, whatever you want it to mean can be whatever it needs to be. But for our purposes, we need to consume it and make sense of it.
When we look at NAS port IDs, I have to have that number. So
All right, so at this point now,
and that's part of the reason why it should just be passed down, and you guys shouldn't know anything about the structure of it. It should just be a string, and that's your NAS port ID.
in a perfect world, yes. In the meantime, we make things work. So the next step is the actual addition of the line card itself. So this is where the first time where we interact with VOLTHA in any meaningful sense to say we're actually going to add the line card, we add the OpenOLT itself. This step right here is where once we run it, we'll start actually seeing the device added in VOLTHA, pre-provisioned device, pre-provisioned OLT being called, and enable being called. Also, at this point right now, given the OLT is plugged in and there's a splitter plugged into it as well, there are ONUs that happen to be here already, but given we haven't provisioned any subscribers or allowed any ONUs access on the network, what should happen after all of the OMCI negotiation is complete is you'll start seeing these devices go into lock state. This is to prevent anybody from just showing up, plugging in an ONU, and expecting service or even physical connectivity, electricity on the uni. This step basically shuts it down hard. Yeah, and so they'll eventually all get there. Yeah, there you go.
Right,
so
right, and that was a hard AT&T workflow requirement.
Right. So yeah, this starts showing the differences in AT&T workflow implementation versus if anybody else wants to come up with their own workflow, it can be coded to your behaviors. But our requirement is we don't let this on unless we're ready.
So that's the
so at this point, we've onboarded an OLT chassis on one of the PON ports. You had 4 ONTs that it did its OMCI ranging, et cetera, brought them online, and then the data rules said, but we haven't provisioned those. They're not in the whitelist, so they become disabled.
Right. So they have an ONU ID that just admin locked. Is the ONU, is that?
Correct. Correct.
Okay.
So at this point here also, we'll probably see this guy show up in ONOS as well. But again, disabled, nobody can do anything, and then the ports is calculated, and then the uplink itself. Just to look around in here, the only flows that should be here should be just the capture flows for the NNI. So any NNI facing flows will have been pushed already, but again, nobody could use it yet because they're all disabled. All right, next step. So days, weeks, months, hopefully not months, goes by, and we're ready to start adding subscribers. And the next call here, again, in the same way, could be called via API, but we're just going to call it via command line. And we're going to add and enable this first particular serial number. This ONU we know is at a person's house. They have their RG. It's all set, ready to go. Slot, port, ONT added. And
so just so we're clear, the slot, the port, and the ONT algorithmically tell me what S&C tags it should have. So that I calculate and send over in the Tosca to and actually the NAS port ID, all the stuff that can be algorithmically retrieved.
It's 91D7. So we should now at this point go back over here, 91D7. Yeah, so now he's come back to life. We're resyncing OMCI, and after some amount of time, it should actually become enabled. The initial MIB is downloaded.
It goes through an EAP flow, which then...
Yep, so now at this point, it's ready to consume the EAP messages that the RG will send. So if we go into ONOS here, we should actually go into our ports. We should see 48, which is D7 is alive. And we probably just have a quick look at the log. And there's our radius conversation. That finished. We could have a look at AAA users. And we have unauthorized user. That one didn't make it in from earlier. And while we're here at the same time, hopefully while I was stalling, subscriber registered. So this is where the event that produced the EAP success said, we successfully authenticated this customer. This is guys allowed to be on the network. Push it to Kafka. Kafka then, that event is listening in Kafka. The AT&T workflow picks up that event and says, we're now ready to provision subscriber flows for this particular user since he succeeded in authentication. While we were waiting around,
And then you plumbed in the SNC VLAN networking.
yeah, so now you'll see the flows for that particular user. How did we come up with the VLANs? The VLANs were determined by the nature of the NAS port ID. This is the AT&T thing that says, based on that string, we calculate out what the SNC tag should be. Wherever that calculation takes place, ultimately, this is where it finally turns into something real. While that was happening, now that the flows are up and the device is ready, and we should actually show it here. Yeah, here we actually see OMCI flows pushed, which means we pushed VLAN, subscriber VLANs. And in the log earlier, we saw it fly by where the DHCP relay picked it up and ran the DHCP intercept.
And that last line says that the IP address has been delivered to.
Yep. So here, DHCP relay allocations, you can see, up there's our venerable NAS port ID and connection point internally to the system, the MAC address, IP allocated. You can kind of see the state of everything kind of bound together here. But from the point of view, from a provisioning interface, we didn't provide any of that as part of coming in. We just said, this is the physical nature of it. We're representing northbound. The rest of it filled in on its own.
So the serial number on this command, your Abstract-OLT command is just adding the serial number of the ONT and also the ONT port and information, ID information into the whitelist. Is that correct?
Well, so there's two calls. It adds it to the whitelist on that particular OLT chassis and port combination. It also pushes the subscriber information over to SATUS, right? SATUS is what wants SNC tags, and ultimately it'll want technology profiles.
We can peek at it here too.
Yeah.
So I'm going to log into the XOS web interface, and you'll kind of see some of the results of that calculation.
Does the push to SATUS occur prior to the 802.1x exchange?
No, it happens after. Only when 802.1x.
Push to SATUS?
Or
well, oh yeah. So that's more of an XOS workflow question. I push the whitelist Tosca and then the subscriber Tosca, just as soon as the whitelist comes back. But XOS itself does the internal orchestration
to add it to SATUS.
And I think it's event-driven, which probably means it doesn't go into SATUS until.
So let's put it this way. This call here will put the data into SATUS, the adding of the subscriber, the allowing it on the network, will put it into SATUS. It's just that data is not queried or used until after 802.1x succeeds.
Yeah, I just bring that up because we have a story right now that is being looked at that will use the actual subscriber information for the 802.1x data path on the PON. So it'll let you use when the technology profile is available, use the technology profile plus the subscriber tag information to allow that traffic to flow. Maybe someone could take a look at that story.
Yeah, just to be clear though, I wouldn't expect to have that handled in Abstract-OLT. I would expect XOS itself to handle that.
Downstream.
Sure.
But yeah. But ultimately, SATUS is where we're looking to get currently just SNC tag. But if it were extended to have technology profile information in there as well, then pull it out and add flows based on that.
Yeah.
So real quick, we'll just kind of look at our whitelist. There's our serial number that we added. This is the PON port ID it's allowed to be on. And really, this is just a reflection of the physical port on the front of the edge core, port 0. So if this serial number shows up on port 0, we'll allow them to talk OMCI to us. If he happened to show up on another PON port, maybe a different splitter, somebody plugged in the wrong port, we wouldn't be allowing him to even participate in the OMCI conversation, wouldn't even look at his EAP if he did produce EAP. So this is why this is crucial to say, I'm allowing this serial number on this PON port before I'll even consider your authentication. And then subscribers, real quick, we'll look in here as well, and we'll see the result of the successful authentication and allocation in the view here. You'll see our NAS port ID, the circuit ID we used to talk to DHCP on the BNG, the IP that was assigned, the MAC address of the RG behind the ONU serial number itself. You can kind of see here the whole thing.
That remote ID is the silly.
Yeah, and the remote ID is the silly. Here you can see the S and C tag that happened to have been pulled from status, which was calculated on the way in as well. No other devices have been allowed, so they're not even in the list yet. So what I'm going to go ahead and do now, just for the sake of progress, is I'll go ahead and turn up the next RG, the next ONU.
May I ask? Oh, so the ONU you are using set up?
Yes, the ONU we're using has an RG already paired with it as well. If that's what you're asking.
All right. So while that workflow happens, let's go ahead and just, for the sake of time,
Dump out the.
Well, yeah, go ahead and generate the backup file that.
That's what this does, right?
So, yeah. So that will. It's not the way we expect to do it, but it will do that. So if you scroll up, there's a command to cat, because it's a very big file.
Oh, that's right. Pretty. Yeah, so this is the state of the Abstract-OLT, what's been pushed in. So the idea being persist this so that if everything restarts, we remember what we have done.
Right. Beyond that, there's not really any meaningful data.
Just seeing that there.
And then again, at startup, it will ingest that and build out the structure.
Yeah.
Everything else is unmapped, so it's just placeholders.
Can you give us an example regarding to how to use this backup file?
Yeah, we're getting ready to.
Oh, we are.
Oh, okay.
See where it says kill Abstract-OLT, restart Abstract-OLT.
All right. So I'm gonna go back to the shell where I happen to have it running in the foreground. I'm going to kill it.
Right, and just restart it.
Just restart it.
And now that's it ingesting the file.
A nice way of saying it read the file.
Yeah, well, it's a nice way of helping me troubleshoot.
Right.
I haven't committed this code, but so if you go back to where you're running the client.
Right.
So now, if you had started it up clean, you couldn't provision to ATL Edge Volt 1 because it wouldn't even exist, right? Nobody's created it, but in this case now we can go ahead and
we can go ahead and get our third one.
Yeah. So again, it succeeded, and then you can do the fourth one. And then you can just watch, and then.
So, yeah, and then let's go back over here. Yep, that was our second one from earlier. And after some seconds, it'll pick up the fact that those last two are allowed, and it'll walk through the setup. Let's see, we got at least our first two. Yeah, there we go. And then we'll check our DHCP. Yep, there's those two. And while we're here, just because we like to actually see things work, I have a shell over here where I run a pinger through the RG, through the ONU, through the OLT, through the BNG, all the way out to the internet, just to prove that it's completely real. And we should have two that are dead, two that work. Yes, the middle two, we made it all the way out. The other two that are still churning aren't ready yet. Yeah, there we go. So we're ready for EAP to happen because those two are there. And we want to see some logs scroll by. Yeah, we got a couple more that finished. Users. Yep, all four authorized. So now we're just waiting for subscriber flows. And this guy takes a minute. There we go. Okay, all four of them are there. So now the subscribers are there, which should mean all the VLANs for the subscribers have been pushed. And we'll just have a look at can't type, look at flows. There we go, a bunch of flows added, they're all happy. And then we'll look at our DHCP relay allocations, which show that not only are the flows pushed, but traffic has passed across them. And we're just waiting for one more DHCP to finish. Yeah, we'll let him come along in his time. Uh-oh, what happened?
What?
Oh, just make sure we're still connected.
Oh.
All right. Maybe we've stalled long enough.
Well, 3 of them have.
Well, they're all claiming push. So it's just one of these RGs is an older one, and he kind of takes his sweet time getting around to doing DHCP. But let's go back over here, and we should have at least 3 of them have come to life. Yeah, we got 3 of them that came to life. So at some point, we'll have the 4th one eventually cross the finish line. But at this point, it's no longer a VOLTHA, SIBA, O&U thing, really. It's just that there it is. That RG finally, last horse finally crossed the finish line. Yeah. So now we have all 4 of them. And let's just make sure all 4 work. There we go. Beautiful. Yes. There's 4 ONTs live with real RGs connecting all the way out. We had a couple other steps in here as well to go through, which I don't know, maybe we can or we can't if we have time or folks want to see it. In the mailing list yesterday, a question came up about an ONT swap and how that worked out. And the scenario here is we had 915B, either fall apart or it's no good anymore. We wanted to swap it out with a newer one, but leaving the RG in place, but also the notion of their ID on the network, the outside network, the NASPort ID stays the same. And this scenario here just shows the removal of the one and the adding of the new serial number, but for the same notation for that subscriber's NASPort ID on the outside network. I can go ahead and do that, but I guess we'll open up for any other questions or folks want to see that. We don't have to go through that, but if anyone's interested,
it's not calling XOS yet, so it'd be a bit of a
right. I got to go run in the table and
smoke and mirrors.
Unplug the ONU. But anyway, we can step through that if anyone's interested. Otherwise, any questions or comments? I think that's it.
You could open up the proto file just so people.
No. Okay.
Back one.
Hold on.
And then API. And then
hold on. There it goes. Which one is it?
The one that ends in proto.
Oh, there it is.
Yeah, so there's the calls. I mean, it's pretty straightforward. People who want to code to that, you can follow the way the client itself is coded.
And obviously, we extend this as we learn new things about provisioning and northbound OSS and what its needs are. But this gets us started in terms of, basic addition of OLT and addition and removal of ONTs.
So one thing we kind of glossed over is you can run Abstract-OLT in a dummy mode, which does everything except send the Tosca over to XOS. But what it does do is take that YAML for the Tosca interface and instead write it to the log file.
This is an example of what gets sent to XOS.
Right. The interesting thing, so we've done some performance analysis, and from a shell script, I could create 10 abstract chassis, each with 16 line cards, with 16 ports apiece, and provision 64 ONTs per. And I was able, just running off my laptop, to process 430 transactions a second. So I know we're aiming it at the pod deployment initially, but really from that kind of transaction processing, we could easily, run it far more northbound. But anyway.
Yeah, the limiting factor would really be the downstream systems that have to be interacted with.
I mean, that doesn't mean you need to, but I just kind of fundamentally opposed to boxing myself in when I have an option. So with that, we can take questions, or we would be happy to yield.
I think we can take a couple minutes if folks have questions.
Hey, Serkan, if you're not speaking, can you please mute?
Yeah. Sure.
Questions? Oh, go ahead, Sean.
So Don, of course, is there any documentation or
Yeah, it's right here.
Yeah, right there.
Right there. I just highlighted it.
And also, so pulling up the usage on both of the client, and this stuff's self-documenting.
What'll probably happen though is there's a set of notes that we use.
Go back to that web page. Yes, it's documented as well.
That we use to kind of run through this. Oh, you mean not this one? Yeah.
No,
The other one?
yeah.
wiki page?
No. The
that
under
one.
SIBA. Yeah.
Hold on.
On the wherever it was.
That one. Oh, that was the very first one. Yeah, I used the same one.
Right, I think Mike Gasser was the one that authored this. This is kind of what I've coded to.
Yeah, I think a few folks have worked at this, and this is our kind of first pass of what we need to kind of do at a workflow level. Mm-hmm. Obviously, more will be added as we get into the weeds on OSS and what its idiosyncrasies are, but this is our starting point.
Great.
Any other quick questions? Oh, go ahead. Danny, did you have a comment?
I had a quick question. So are the ATT OSS systems ready to interface with Abstract-OLT today through REST interface, or is that something that's being still developed with tech dev?
I was at a kickoff meeting immediately prior to this one, but I don't know. If Smitha's on, she might.
Tech dev will not interact directly with the Abstract-OLT. It will go through another layer called Awesome, and that is under development. So neither the tech dev nor the Awesome is currently available. Awesome will have to get developed first, and then the idea is that tech dev will have a much simpler interface than it has had in the past to network elements, and Awesome and SIBA and this Abstract-OLT enable that. But the next step will be the next layer above this layer is Awesome.
Yeah, I think some of
for AT&T.
Some of the detailed discussion we can do it offline. I think Danny and we have of course we welcome AT&T's tech support. Danny and Chris and Mark, they were involving today on this call.
Okay, so let me jump in because I didn't realize you guys were going to be there. So when we do a build out at a CO, those first two things you see there, the creating the chassis and assigning it a SILI, and then onboarding the OLTs, that would likely fall to whoever's doing the actual build out, whether it's ATS running it or some proxy of ATS. Everything else would be expected to come from the northbound OSS. Does that make sense? And, I guess the one thing I would say, and we probably need to spend a little more time, but the order that you onboard the OLTs counts. So that you can plug fibers into the correct ports.
And in this case, OLT meaning the round edge core, but in our terminology is the line card, if you will.
But once we get the pod delivered to ATS, we'll go through that exhaustively.
Sure. Thank you.
Yep.
Okay, I think we probably need to move on to our next topic. So thanks, Foundry, for the demo. Much appreciated. And
Julie, sorry.
Yes.
I do encourage other service providers to take a good look at this one and see whether this can be adapted into your workflow. And of course, this is basically specifically based on AT&T workflow, but I think there's some of the calls to the XOS and other to the SIBA. I think those will be a good example for other service providers if the NAM and SIBA portion will be utilized. So, okay, thank you. I would like to have a great thanks to Foundry to put this together. It's a very good demo. And again, it will be recorded. So it is being recorded. So.
All right.
Hello, Sean. Actually, thank you for bringing up this, and thank you the AT&T founder that demoed this workflow to us. Actually, I'm working with the ATT Workflow, and I think in a couple of days we will set our requirements related to this Abstract-OLT. It's almost same, but we will have some minor differentiations.
Great.
So under the SIBA JIRA, there's an Abstract-OLT epic. If you're going to ask for functionality changes, that just a user story on that epic would be great.
Yeah. Okay. Sure. We can use this way.
Thanks.
To reflect our new requirements. Yeah.
Okay, Julie, back to you.
Thank you. Our next topic today is we had some requests for a code walkthrough on 733, see if we can get this one to move forward and get the work merged in. So, Cora, I think I see you on. May I give you presentation rights?
Yes, my screen is ready. Julie, thanks.
Great, thank you. Okay, hold on. This is doing something it hasn't done before. Hopefully this will work okay.
It says that I need some add-ons that needs to be installed, so
yeah, that's what it said when I handed it over, so it may take a minute.
Okay, I think I have done it.
And all right, I believe I see your screen.
Can you see my screen?
Yes.
Okay, thanks. So hi everyone, this is Koray from Netsia. So today I am going to make a quick code walkthrough of the issue 733, which is basically related with the technology profile implementation. And I am going to do this, code walkthrough in order to speed up the review progress of the corresponding issue. So without losing so much time, let me start quickly. So the main, implementation that we consider under this issue is basically adding some, capability to the off-agent controller to handle with the meter mod request and the meter stat request OpenFlow messages. So when the OpenFlow message is received by the OpenFlow protocol handler in this while loop, the main handler function table is called, and for example, assume that we received a meter band meter mod request function, OpenFlow message, then we call this meter mod request function. What this function does is nothing but it just converts the OpenFlow meter mod request function, message to a gRPC message basically. So this to gRPC function gets called and it converts the OpenFlow message to the gRPC message according to the type of the the message, where we added here the meter mod request message type, meter stat request type, and the meter band subtypes. And I am going to talk about that in a short while as well. So let's assume that the OpenFlow message that has been taken from the controller was a meter mode message. Then we call this converter function, and it simply just copies all attributes of the OpenFlow message to the gRPC fields. And there is a for loop in here in order to handle with the meter mode messages meter band attributes. Please note that the meter mode OpenFlow message can include any number of meter band sub messages of type band drop, DHCP remark, as well as experimenter. So this for loop does nothing but the same thing that we have done in here to convert the OpenFlow messages to the gRPC messages, just like here. So in order to make this happen, we needed to make some changes in the OpenFlow proto file as well. Let me show it in here. Where is it? Okay, I'm going to show it in here.
Hey, where'd you get a GoToMeeting client that runs on Linux?
Excuse me?
Where'd you get a GoToMeeting client that runs on Linux?
I don't know, because I am using Chrome web browser and it just forwarded to me.
Because we did it off Matt's laptop because my Linux laptop, I've never been able to get GoToMeeting run. Sorry, go ahead.
That's okay, thanks. So the meter band header has to be changed in this way. Basically, it would be better to show you guys the previous version of this file in order to, okay, I found it. So the previous, oops, I'm sorry, where is it? Okay, here it is. So the previous version of the file is implemented in a way that the meter band header message can be instantiated and sent to the OpenFlow slave like OpenFlow switch from the controller as itself, but it is not by itself, but it is not possible according to the specification of the OpenFlow 1.3. So the type of the meter band can be of type meter band drop, meter band DHCP remark, and the meter band experimenter, but nothing else. So this meter band header is something that is common for all of the subtypes of the meter bands, as you can see. So I changed the proto file in a way that the common parts are moved forward to the meter band header and they are deleted from the subtypes. And at a given time, when we have a meter band header message, we will only have one instance of these subtypes inside a given meter band message that is transmitted from the controller, and the type of this subtype is indicated, explicitly indicated basically with the type field of the message. So I changed the proto file that way, and let me go back to the Python site. So back to the converter, where is it? Okay, once I converted the OpenFlow message to a gRPC message, I sent it to the gRPC client's update meter mode table, which is also newly implemented, along with the device ID and the gRPC request file. Sorry, gRPC request message. So this function does nothing but very similar to the one that we have just talked about. It creates a new gRPC message, which includes the meter mode gRPC message, as well as the device ID, which corresponds to OLT device ID that if I am not wrong, but I am not sure. And then this meter mode update request message is given as a parameter to the gRPC server's update logical device meter table function, and it is called in a different worker thread in order not to for the, not to wait until the end of the response of the, the called function from the server side. So I just return from this function from at here, and once the result of the function is ready, my program continues to run from here, thanks to the inline callback decorator, basically. This is the property of the twisted framework of Python. All right. So this is the okay.
So my ignorance. So by changing the OpenFlow proto, we are actually changing the gRPC messages. We are not touching any of the OpenFlow message type, right?
No, we are not touching that. We are just I just touched the way that the proto file handles with the meter mod request OpenFlow messages at the off agent site.
Okay.
Is it clear? So, is there any questions so far? All right, I keep going. So, well, let me talk about the gRPC server side, basically. So the update logical device meter table RPC call is defined in the VOLTHA.proto file as just like that. It takes a parameter which is named as meter mode update, and it returns nothing basically. And it has an option of RESTful API field, but I am not sure about that field since I am not very familiar with the RESTful kind of things. I just cheated it from the previously implemented RPC calls basically. So this field, this portion of the update needs review basically. All right. This is the first part of the update, and the second part is basically about the meter stats request. It is very similar to the meter mode request, but it is kind of simpler than this because in this time we do not need to convert the OpenFlow message to a gRPC message since we are not going to send it to another container or another working block within the VOLTHA infrastructure, since we know that the controller is requesting from us to send back the meter statistics to the controller. So I just make an RPC call for the meter statistics with that function, which basically creates a gRPC message and calls the get meter stats of the logical device API function call, which is also defined in this proto file. Basically, it takes the device ID and it returns the meter stats reply. So the implementation of those two RPC calls are put to the local handler of the VOLTHA core, but the inside of them is not implemented basically since because it is a requirement which is since it was not the requirement of this issue basically 733. So is there anything left? So yeah, since the once the meter stat requests are received from the local handler, they are basically converted to the OpenFlow messages from the gRPC messages, which is basically the, you know, I mean, in the meter mode request case, converted the OpenFlow message to a gRPC message, but in this case, we are converting the OpenFlow message to, gRPC message to OpenFlow message. So we are doing some kind of vice versa operation. So once the meter stats are converted to the OpenFlow messages, they are transmitted to the OpenFlow controller by the OpenFlow connection instance of the OpenFlow protocol handler. So this is all basically what I am going to tell in this file. Let me see if anything remains untold. Where is it? Here it is. No. Here it is. So we talk about, the test functions. There's only a single unit test case in here that I have implemented basically, and it is very simple. It's very straightforward. It creates a meter mode OpenFlow message and converts it to the gRPC message and compares the original values with the gRPC messages corresponding fields values, and if there is not any inequivalence, the test fails. And in order to make it more generic, I put some randomness. I put some randomness inside the test function, like the meter band's entry count value maybe between 0 and 20, and the OpenFlow meter mode message type can be add, modify, or delete. Yeah, this is kind of detail, but there's some randomness and generic test function cases written in here. So that's all basically what I am going to say. If you guys have any further questions, you are most welcome.
My comment is, so this is related to the traffic. Sean, is this related to the technology profile related stuff?
Yeah, so this is basically adding support for meter bands and validating the meter bands.
Okay.
That get passed down to the flow decomposer area, I guess, and the adapters.
Okay, so I have a request. Maybe this one will not include until we cut the 1.5.
Well, this is on the master branch, right? I mean, so
it has not been merged in.
It is not.
Yeah, not yet. Yeah.
Because I don't know. I think there are some necessary changes required in order to support this, but I just don't know whether that will affecting the functionality of 1.5 try to achieve. I think this is good work, but I think maybe the final merge need to happen after the 1.5 being cut.
Yeah, I mean, we don't use meter bands currently, so it shouldn't affect anything. But if you want to hold off, I guess that's fine.
It might not be too bad to add, but we just need to make sure in, I guess, the device adapters where they start decoding the flows, that they don't throw an exception and they just ignore it if they see a meter band.
Right.
No one's generating meter bands right now, through OpenFlow. Yeah.
And also, I think there are some fixes in the OLT pipeline that we might want to look at that are part of this fix.
Right.
Is there a related story for that? Maybe make this dependent on that.
Don and Matt, do you guys have any, while Chip is looking, do you guys have any comment on this one?
I mean, it's kind of like Chip said, if it's all new work that nobody's using, then it's probably safe, but the trick is going to be if there's some unhandled error that happens in a very tested path and everything stops, then now we're all stopped. So yeah, I mean, it's without trying it, there's no way of knowing, but that's really the only concern.
If we don't need it for 1.5, I'd prefer it to be post 1.5.
Right.
Just so that if something goes wrong, we're not pointing at this first and then finding out it's something else. Just if it's functionality we're not going to use pre or at 1.5 or before, then I would prefer. You're planning on forking Friday, right? Or
this week or early next week. Yeah, I'm really waiting for. I think Chip has some stuff that I want to make sure he's got in what he wants, and then we can call it.
Okay. Yeah, I think
I want to get 1.5 cut as soon as possible because I don't want to get in the way of the 2.0 work.
Yeah.
This stuff.
The tearing adapters apart work, which has to happen.
Yeah, everybody starts cherry picking everything. It's like, well, this is really messy and
yeah.
So as soon as we can.
Okay. Yeah, is there a story that represents the 1.5 branch that we could block the story against, or we don't do that? We just wait until the branch is cut and then everyone just merges their code.
Well, that sounds like a Jono question.
Could be waiting a while for that one.
Well, see if you can contract him back. I have no idea what the normal practice has been.
I mean, it certainly won't hurt to have one, but yeah, I guess it depends on what we've done in the past.
But really, Chip's on, right?
Yeah, I'm here. Yeah, okay. Yeah, I had this confused with another one, so this doesn't have any OLT pipeline changes.
No, I was just. Oh. You got some work you want to get into 1.5.
And there is also one Irish request on the Jira 1236. I think that's the traffic the profile still under the config. I think Deutsche requires that one. Girish, am I true? Is that for the traffic distributor profile?
Yes. So there were some changes done for TT. So we are pushing that one. Yes.
Okay. So I'd like to insert myself here for just 1 second. Do we have any questions for Corey right now on the code? If not, I'd like to take presentation rights back. I want to give him a chance to answer any questions first. Okay, I'm not.
Also, I guess we just need to have this signed off at some point as well.
Right, and that's the next item I wanted to get to.
Okay.
So I think I'll go ahead and take presentation rights back. And so, Sean, I did hear your request and that from some others to, let me get the right screen up here, to delay the merge for this until post 1.5, and it sounds like the target is early next week. What I do want to address with the community right now, because this has been out there for a while. Chip, I know you've done a review of this, so thank you very much, but we still need to find out who is the right person once we have 1.5 cut that could do the +2 for this. So we need to make sure we have someone identified who will be taking care of that, because that's been an issue.
I reach out to Sarav and see whether he can also take a look at this.
Okay.
So I think I'll add Sarav's name on it. Sarav's name is not on the reviewer, right? So I'm going to add it.
Okay. And
Okay.
then with the keeping in mind, I think the discussion now to defer the merge until the 1.5 is created. Okay.
Right. So,
I wanted to make sure that
okay.
at the meeting we had a path forward for this issue because it's on hold for quite a while.
Okay.
Thank you. All right. Is there any other discussion we need on this item today? Okay, Corey, thank you for the walkthrough and thank you for everyone for the discussion. Let's go on to our next agenda topic. And we've got about 24 minutes left. So we've got 2 items. The next one, I believe, Shad, are you still on the bridge?
Shad has left, so he has a detailed discussion on the VOLTHA discuss. He has the proposal regarding to how to move the adapters. So I would like to just bring up everybody's attention on that one. Take a look at the VOLTHA discuss, and then maybe have the VOLTHA discuss feedback. Potentially, if we need, then Julie, maybe we can bring that back in next Tuesday if we have time.
Okay. All right, thank you for that. Okay, so that actually gives us some time back today. Ed, do you want me to go over to VOLTHA discuss to bring up that discussion for folks to do anything right now with that, or just defer it completely?
I think just defer. I think people should, if they follow VOLTHA discuss constantly, they should know that.
All right, sounds good. Then the last item we have today, then Sean, you'd requested for an ad to introduce Craig to the group. He's been on the meeting for a bit. And then an opportunity to talk about the addition of the Labs OpenOLT, and then figure out the timing, like post 1.5, pre 1.5, what needs to be done in order to add related Jira stories and tasks. So Sean, let me hand it over to you right now to introduce Craig. John?
Craig, right?
Yes.
Yes.
I was handing it over to you to introduce him, but I can just hand it directly to Craig.
Okay, so Craig, why don't you just introduce yourself? I think that's a better job.
Yeah, thanks everyone. As Julie said, I've been listening in on the calls for a little while here, and we are working on and integrating the OpenOLT adapter and agent on our OLT platforms at Tel Labs, and looking at being a contributor to the VOLTHA community in that regard, as well as moving on to looking at contributions to help with the project in passive optical LAN applications and enterprises. So, we've been talking a little bit with Sean about how we can help out with the community in that regard. But our first objective is to work with the OpenOLT project with Shad and the team to get that platform or that component working on our hardware. And we have a few minor updates and new tasks and Jira items to get committed that we need to understand what makes sense from the community as far as getting those included before or after the 1.5 release is done.
Thank you, Craig. And unfortunately, Shad left already. I think we still have Foundry folks on who've been working on OpenOLT as well. So I'll see Sean or Foundry folks if you have any comments, or others from the community in terms of timing.
No comment. Just
what's your form factor?
We have a couple different form factors, but the primary one is the 1RU.
Okay, like 16 ports, or?
It's an 8-port device.
Okay, cool.
Yeah, well, welcome, and appreciate the help.
No problem. Abstract-OLT can handle it.
You bet.
And I guess with Abstract-OLT with 8-port, you can probably have more than many slots. Okay, that's great.
Yeah, the mapping in Abstract-OLT is port to port, so I don't really care how many chassis.
Yeah, I mean, the really
we also have
clever
a hardened remote OLT also 4-port device.
Okay. Yeah, so curious things about the uplinks,
Yeah?
the NNI.
Actually, that you just got me very interested. Can you send me one?
Oh, okay.
In November would be soon enough.
Okay, Volt.
Okay, so
Yeah.
we're going to circle back around here. So in discussion timing for the JIRA stories, I think, Craig, let's go ahead and have you enter those stories, and then on Tuesday's call, when we go over new JIRAs, then we can talk about the timing of when to merge in related work for that. Or absolutely, yeah. So I think pass forward. Shad's not on the bridge today, or he was earlier but had to leave. Sean, does that work for you as well?
What I was saying is, so I do believe that Lab's effort is try to integrate their device into the OpenOLT adapter first, right? So, and so the TELAB, are you guys targeting 2.0 for the integration? Because I guess 1.5 right now we're cutting in the next week already. So I think the 2.0 is your integration target, right?
I believe so. If Shad's statement that 1.5 is going to probably live for a while, it might make sense to have it someplace there, but someplace so that we have an active branch that we can make commits to with the work. And but 2.0 probably is the right target.
Okay.
Yeah, so that does into the discussion on the adapters as well. Sean, you had another comment?
No.
Okay. All right, so Craig, go ahead and enter those stories, and then we can review them on Tuesday's call and have more discussion. Do you have any other questions for the group today?
No. Not today, thank you.
Great, okay, thank you. And I think with that, since we're going to put the discussion on the adapters and the 1.5 and 2.0, we'll have that discussion over the Exploder on VOLTHA Discuss. Then we'll get a little bit of time back today, which I did not expect. So let me check with the group. Do you have any other topics that need to be addressed with the larger community today?
I do have one comment on the TELAB's integration to the OpenOLT. So right now we have a story that we're working on for a resource manager, which defines basically the allocation of the GenPod IDs and ALEC IDs. And so if you look at the story, let's see, what was the story? If you look in Vol 731, which is the epic for technology profiles, there's a story in there for a resource manager. And so if you could just take a look at the algorithm that's being used to allocate the ALEC IDs and gem ports, and if there's any variation that we need to know about or accommodate from that, could you maybe let us know or update the story or something like that?
Yeah, I can definitely do that. And right along the lines of some of the changes that may have been necessary, we got an initial version of the OpenOLT from VOLTHA 1.3 operating, and those were definitely some of the areas of change. So I'm familiar with those requirements, and I'll take a look at what you're doing there.
Yeah. So right now there's an algorithmic way of allocating those values, and we're implementing a resource manager that you give it ranges of what you're interested in allocating, and it can allocate them for you. So if there's any specifics around any detailed unique behavior that's not accommodated, if you could just let us know what that might be, and then we could maybe look at accommodating that.
Sounds good, Sean. Thank you.
All right.
Thanks, Sean. Any other
on that resource manager aspect, I do remember, Sean, you made a presentation on that. But I don't remember the outcome. Is the resource manager has been the concept of creating a resource manager has been, is that moving forward?
Yeah, we have Girish has an implementation of that right now that's kind of been under review, and it's getting close to being ready to be merged in. So if there's anything, we can, accommodate from requirements there, maybe it'd be good to add those in, or basically you can create another instance of the base class and accommodate any specific code changes that might be needed there as well.
But is the resource manager target for the 2.0 or 1.1x? I mean, I guess it's once cut, everything's still back in the master, right?
Yeah, so it's going to be on the 1.x line right now. But obviously, if it's going to affect the, we don't do, I guess, merge it in before you do the cut of the 1.5 release. So
yeah, when
that happens, it should freeze up.
Right. And the other thing, are you aware about that the Jira 1236 for the I think that's for the Deutsche Telekom, right? Sean?
Sorry, I was on mute.
On the screen.
Okay, well, let me take a look at it offline and I'll get back to it.
I think, so my question is, is Girish still on?
Yes, Sean, I'm there.
Right. So is this utilize the XPON config and on the ASF VOLT 16 adapter, right?
Yes.
Okay.
And what's your question? I mean,
I remember this one, but okay. So, sorry, go ahead.
The question is TDP. I would assume is traffic descriptor profile. The concept of the traffic descriptor profile is part of the XPON config for the 1.2 release, right?
Yes.
Okay. So your request is to have 1.5 include this one. So I just I'm working on with other reviewers see whether they can pull this in. Matt, do you think there will be any?
It shouldn't affect anyone because it's to do with ASF VOLT 16 adapter.
That's what I meant. That's what I think.
Yeah, that's not going to hurt us. Yeah. Go ahead.
Right. So
depending on when we branch, I don't know if it'll make it in before or after, but I mean, if it's unrelated to OpenOLT and its drivers, then I don't see how it would be harmful.
Right. I think this is the Deutsche Telekom requirement. I do want to put it into 1.5. So I think right now it's already have a +1 review. So I think I just need someone to do the +2.
I think Amit has the permission for that.
Okay. Then just go ahead and do that.
Okay.
Okay. Really sorry I added this agenda, but I think
that's all right. Any other topics we need to talk about today?
Okay, I think Girish, I think if you guys can do a +2, we should be fine.
Okay, thanks.
All right, then I think we have so Tuesday we'll be going over status updates for Sprint 8, which is in flight, and probably talk a bit also, make sure things are on track for 1.5 if it has not been cut yet by Tuesday's call. Next Thursday, we tentatively have planned the review at the code walkthrough on 5.06 and related review and discussion. And then the following Thursday, so 10/11, October 11th, the BBSIM discussion that was requested by Foundry. So that's on the agenda in a couple of weeks. With that, I think we will wrap up for today. I'll give you just a few minutes back. Any last comments before we drop the bridge? All right, I will stop the recording. Thanks, everyone.